So good morning, everyone. And I think this is alternating current lecture number 3. Now, in the last class, what we had discussed, was something known as the impedance of a circuit. And as you remember, you might recollect, the impedance of a circuit is denoted by the letter Z. It basically tells us the effective resistance to the flow of alternating current. Now, we have seen 3 types of circuits. Purely resistive circuit, the impedance of that circuit comes out to be R. For purely inductive circuit, it comes out to be XL, which is equal to omega L. And for purely capacitive circuit, this impedance Z. Remember, the SI unit of Z is same as resistance, which is ohm. SI unit of XL, which is also impedance, is ohm. SI unit of XC, which is also impedance, is ohm. And we know this result IRMS is VRMS divided by Z, or I naught will be equal to V naught divided by Z. In all the cases, in all the circuits that we are going to do, whether it's a pure resistive circuit, pure capacitive, pure inductive, or any combination like LR, RC, and LRC. I hope we all understand this. Now, what again, I'm going to tell you something, and I hope that you make sense out of this. Now, this is the time that I must introduce you to something known as the power factor. And I hope everyone is noting this down. Power factor. In short, it is known as PF. It is not Provident Fund. Your mom and dad would be having this PF if they're working with some good organization. PF, Provident Fund, many a times. Your dad has to break this Provident Fund to pay fee for your college. I hope that day doesn't come. Power factor is what we are talking about. Now, what is this power factor? What is this power factor? If I have to tell you about this power factor, now I can describe it in different ways. I can describe it in different ways. What I'm going to do is I'm going to try my best and make you understand in the simplest possible way. And I hope that it makes sense to you. If it doesn't make sense to you, don't worry. It will be making more sense when you understand this. Okay, this is a right angle triangle. I hope all of you see this right angle triangle. Now, in this right angle triangle, you know this side is the hypotenuse. This is the hypotenuse. This is the perpendicular, and this is the base. Wow, why I'm telling you this? Why I'm showing you this right angle triangle? Because this might come as a question straight away in your NEET exam, and you must be able to understand this. So we all understand this. Hypotenuse, perpendicular, and base. Now, if I draw this hypotenuse, perpendicular, and base in terms of what? In terms of what we have understood in this chapter of AC. In this chapter of AC, we have come across 3 different types of terms. The first term is Z, which is the impedance. The second term is R, which is the resistance. And the third term is XL or XC, which we called as reactance. I hope XL is inductive reactance, XC is capacitive reactance, but they all come under the category of reactance. I hope I am making some sense. This is your impedance. And remember, all these terms refer to the same thing. They are trying to make us understand the same thing in different ways. This R stands for resistance. I hope everyone is paying attention. This R stands for resistance. This blue one, XL or XC, they stand for reactance. I hope I am making sense over here. Even if I am talking nonsense, just remember what I am going to tell you now. Now, these three quantities are related to each other by a triangle, right angle triangle. Now, how they are related? Your Your Z is your hypotenuse here. The impedance is the hypotenuse here. The resistance is your base here. And the perpendicular is your X. Now, this could be XL. This could be XC. This could also be a combination of XL minus XC or XC minus XL. So this can be XL or XC, or it can be XL minus XC, or it could be XC minus XL. Don't panic. I'll tell you in what case, whether it is XL or XC or XL minus XC or XC minus XL. Just remember this X wala component, this is known as reactance. Perpendicular is the reactance. Base is your resistance. And Z, impedance, is your hypotenuse. I'll give you a minute to note it down. Now, before going any further, I must also add here, this is phi, angle is phi. This is Z, this is R, and this is XL or XC. Now, instead of calling it as XL or XC, let us call all these combined terms as X, so that we can use this for XL, you can use this for XC, you can use this for XL minus XC or XC minus XL. Now from here, what I can do is I can find relation between these three. And the first of these relations, and the first of these relations would be my Z will be equal to under root of R square plus X square. Do we understand this? Oh, you can't raise your hands. I hope you have understood this. Hypotenuse is root over perpendicular square plus base square. I hope this is making all sense to you. Even if I am talking nonsense, you remember this. This is the first thing that you can understand from this right angle triangle. And that is why I've drawn this right angle triangle. Now, the second thing that you can understand from this right angle triangle is something known as the trigonometric ratios. The first thing that I'm going to discuss here is cos of this angle phi. And you can find out this cos of the angle phi by base divided by hypotenuse. Base divided by hypotenuse is my cos of phi, bacha. And this cos of phi, not phi, this cos of phi, not phi, this cos of phi, not phi, the value of cos phi is known as your power factor of the circuit. Power factor or PF of the circuit. And you should not remember it. You should not forget it till the end of your life. When I say end of your life, I mean till the day you give your NEET exam, because after that you might not need it. Cos of phi. Now sin of phi you can also find out from here, but sin of phi is not that important. The other important thing is tan of this phi. tan of this phi. Tan of this phi, because we'll be most of the cases dealing with either cos of phi, which is the power factor also, or tan of this phi. And you can easily find out that tan of this phi is perpendicular divided by base, so it will be equal to x divided by r. That will be your tan of phi. From here, I can find out the value of this phi. I can also find out the value of this phi from equation number 2. But normally, whenever someone asks you the angle, the value of angle phi, you basically find out from the third equation, not from the second one. You find out from the third equation. You find it out from the third equation. You find it out from the third equation. The value of phi, as you can all see, is tan inverse. You'll find the inverse angle, tan inverse x by r. And I hope you remember it. I'll give you a minute. You can win it. Well, I hope you have noted this down. Let us now move and see the same thing in a different way. And what is that different way? Now, again, I will draw that right angle triangle. Again, I will draw that right angle triangle. The same right angle triangle. And again, I draw this angle phi. Cos of this phi is power factor. What I can do here is now I will mark them. And again, this might come as a question here. I can mark this in a different way. I can mark this like this. See carefully. I mark something known as power PA, PV, and PR. Oops. What is PA, PV, and PR? Now, this PA is known as the active power, which is the average power this circuit uses. Active power, or sometimes I can call it the average power. Active power or the average power, it's not off, it's on, or average power over one cycle. Now, this average power or active power is the power that this circuit consumes in one cycle. One cycle means one rotation. 1 revolution, 1 complete circle. The frequency of the light that I'm using is 60 hertz. In 1 second, it is taking 60 cycles. In 1 cycle, how much power it is consuming, how much power my lamp is consuming in 1 cycle, that is the average power. That is the active power. That is the average power or the active power. Now, how do I find the value of this average power, active power? You don't have to see how it comes. You just have to remember the formula. And the formula is, the first formula is VRMS into IRMS multiplied by cos of phi. This is my active power. This is my active power. VRMS, IRMS, cos phi. Now, since this cos phi appears in this active power, and that is why this cos phi is known as the power factor of the circuit, because this cos phi determines, this cos phi determines, this cos phi determines how much power the circuit is consuming. And therefore, this cos phi is known as the power factor of the circuit. Now, if you look at this green one is known as your virtual power. This green one is known as your virtual power. So PV is known as your virtual power. Now, this is the total power that the circuit uses, that the circuit takes, but it does not use it. Some part of it is given back. AC circuit takes some power from the line. This bulb is taking some power from this ghar ki line, but some part of this power is only used, the other part is given back. The total power that is taken, some part of it is given back, that is known as the virtual power. That is known as the virtual power. And how do I get the value of this virtual power? This is simply equal to VRMS multiplied by IRMS. And you can see that cos theta wala factor is completely missing. That cos phi, not theta, cos phi determines the how much power it has used. That is known as the power factor. I hope I am making sense. Even if I am not making sense, if I am talking nonsense, you just write my nonsense. So this is, oops. This is VRMS multiplied by IRMS. Don't forget this. This is VRMS multiplied by IRMS. This gentleman, this gentleman is, I hope all of you are writing this VRMS, IRMS, cos phi. Now, no one is going to ask you the third thing, but it is very easy to understand what would be the third thing. It's a right angle triangle, remember. It's a right angle triangle, remember. This PR is known as the reactive power. Reactance, reactive power. Now, this is the power which is not used. This is the power which is not used. It is taken, but it is also given back. I don't use it to take it back. The circuit takes it, but it gives it back. I don't want it. Keep it. Reactive power. Reactive power. This reactive power comes from reactance. Reactance is XL or XC. So power in XL or XC, power in an inductor or capacitor is not used. Inductor and capacitor do not consume any power. Inductor and capacitor do not consume any power. Remember this, note it down. Inductance and reactance in AC do not eat, do not consume, do not use any power. Then who uses power? Then who uses power? Then who uses power? We'll come to that. Only one element uses power, and that element is your resistance. But first, let us write the formula for this. My reactive power simply becomes right angle triangle. You can tell me it will be VRMS into IRMS multiplied by sine of this angle phi. This is my reactive power. No one is going to ask you this, but this is for you to understand this. So this becomes VRMS into IRMS into sine of the angle phi. I'll give you a minute, 2 minutes. If you have any doubts, come up. Well, I hope you have noted this down. I hope you have noted this down. Okay. Now, what we are going to do is we are going to concentrate much on the average power or the active power, PA or P average. You can write it like this, or you can write it like this. Doesn't matter, is the one and the same thing. Or simply, whenever someone asks you, what is the power of this AC circuit? What is the power of this AC circuit? What is the power of this AC circuit? They are talking about, they are talking about, they are talking about the active power or the average power. Remember that the formula for that is already seen. VRMS into IRMS into cos of phi. This is the formula, cos of phi. Now we are already accustomed to this cos of phi. This cos of phi is known as the power factor. But what is this phi? Cos of phi is power factor. What is this phi? Let us now elaborate this phi so that we get everything clear up. Cos phi is known as the power factor PF. Yes. What is this phi? This phi, if you remember from the very first class, this phi is the phase angle or phase difference between voltage and current. This phi is the phase difference between voltage and current. Voltage and current. Phase difference between voltage and current. If I take case number 1 for purely resistive circuit, for purely resistive circuit, for purely resistive circuit, the value of this phi is 0. Cos phi becomes 1. Cos phi becomes 1, and your average power or power becomes VRMS into IRMS. Please remember this. Please remember this. For pure L or pure C, the value of this phi is plus or minus pi by 2. Why I'm saying plus or minus pi by 2? In one case, voltage is leading. Voltage is leading in the case of inductor. In the other case, the voltage is lagging in case of capacitor. So plus pi by 2 or minus pi by 2. The value of this cos phi becomes 0, implies the average power becomes 0. Average power becomes 0. From here, we can understand a very important point. We can understand a very important point. L or C does not, L or C circuit does not consume any power. They do not consume any power in a AC circuit. Power is not consumed by L or C. Then who consumes power? Only resistance R consumes power. You should not forget this ever. In a AC circuit, only resistor consumes power. This is the first way of writing this equation. This is the first way of writing this equation. I'll give you one more way. I hope you are noting it down. I'll give you one more way of writing this equation that makes it very clear for us to understand that only resistance includes, only resistance consumes power. And how will I write it? Power average or P average or PAV is simply equal to I square RMS multiplied by R. If there is no R, the power consumed is 0. Only R consumes power. So this is another way of writing the same formula that I have written here. Either you can write it as VRMS into IRMS into cos phi, or you can write it as I squared RMS into R. Both the formulas are same. Remember, the value of cos phi is R by Z. I'll give you a minute to note this down. If you have any doubts, please ask. Well, I hope you have noted this down. This is again the same thing in the form of textbook language. Power factor is equal to the ratio of R resistance divided by impedance of the circuit. Remember that. Point number one. Point number two, power factor depends on the nature of components. How many component it has? It has R, it has XL, it has XC. The power factor depends on this. In a case of pure resistor, then phi is 0, cos phi is 1. So your average power becomes ERMS into IRMS. ERMS is VRMS, or you can write it as I square RMS multiplied by R. Remember, only resistance consumes power. Power loss is maximum and electrical energy is converted in the form of heat. So if I have a pure resistor, if I have a pure resistor, the power loss is maximum. A question can come, what type of circuit, what type of AC circuit consumes maximum power? Pure resistive circuit consumes maximum power. Please note it down. I hope you have noted it down. The next part is where we understand what happens in a pure inductor or a pure capacitor. The value of phi is plus or minus 90. That means cos phi, which is your power factor, is 0. If cos phi is 0, the power average, there is no power consumed, thus there is no loss of power. Thus there is no loss of power. So this is what you need to understand. If it is a pure inductive circuit, the loss of power is 0. They do not consume any power. They do not consume any power. So we have seen the case where it's a pure resistive circuit. In a pure resistive circuit, phase angle phi is 0. If it is a pure inductive circuit or pure resistive circuit, phase angle is plus or minus pi by 2 depending on whether the voltage is leading or the voltage is lagging. Now, we have seen two cases. Case number 1, we have seen 3 cases probably. Case number 1, angle is 0. Case number 2, angle is plus pi by 2. Case number 3, angle is minus pi by 2. 0, plus pi by 2, minus pi by 2. But again, these three cases are not the only cases which are possible, because angle could be anything. Angle could be anything. Angle could be anything between 0 to 360 degrees. It could be 30 degrees, 45, 60, 90, 90 we have seen, 120, 150, anything. Angle between voltage and current, if this is current and this is voltage, current, voltage, current, voltage. Angle between voltage and current could be anything. Angle between voltage and current could be anything. I hope you are understanding this. This is my current. This is my voltage. Current, voltage. If it is like this, same phase, they are in the same phase, pure resistive. If voltage goes 90 degrees ahead, it is pure inductive. Voltage is ahead, current is piche 90. Reversing happens like this. Current, voltage, current is ahead, voltage is lagging, pure capacitive. But we have only seen 3 cases here. 0, plus 90, minus 90. It could be like this, 30 degrees. It could be like this, 45, 60, or anywhere. The question is, when will these cases come? When will this case come? When will this case come? Tell me, when will this case come? Well, these cases will come when you have a combination. When you have combination. Combination of what? Combination of a resistor with an inductor or a capacitor. So you will have this thing whether when you will have LR circuit, RC circuit, LC circuit, or a combination of all 3 LRC circuit. In pure R, angle is 0. In pure L, angle is plus 90. In pure capacitance, angle is minus 90. We are assuming that voltage is behind. We are taking voltage as behind. We are talking about angle of voltage. But this is not only 3 cases. There could be infinite number of cases. And these infinite number of cases will happen in different types of circuits, LR, LC, RC, or LRC. So this angle could be anywhere between, could be anything. It could be anything. When it is anything, you have to find the value of this tan of phi. And remember, tan of phi, I have already discussed, is x by r, where x is your reactance. Now this reactance you will have to find out. But in any case, your cos phi will always be equal to r by z. Here they have written the formula here as xl minus xc divided by r. It could also be xc minus xl divided by r. It could also be xl divided by r. It could also be xc divided by r. In which case it is what? That we will see just now, right now. Please note this. I hope you have understood this. I'll give you a minute to note it down. Take care. Well, I hope you have noted this down. As I can see, as I told you, there could be many number of cases possible. We look at the first case and we look that in very brief. This one, LR series circuit. So it's a combination of R, which is resistance, and L connected across a connected across a AC source. V is equal to V naught sin omega t. Now remember, if it is pure R, they are in the same phase. If it is pure L, voltage is leading current. Voltage is leading current by 90. But when I combine these two, in one case it is 0, in the other case it is leading by 90. So what happens? This is the voltage across inductor, it is leading by 90. This is the voltage across resistance, which is in line, same phase. As you can see, now the voltage leads the current, but not by an angle of 90 or by an angle of 0. Voltage is leading by an angle of phi. What is the value of this phi? Tan of phi is XL by R. XL by R. Cos of phi is again R by Z. And what is the value of Z here? What is the value of Z here? This is the value of Z here, bacha. The value of Z. Oops. The value of Z is under root of R square plus XL square. I hope all of you can see this. The value of Z is under root of R square plus XL square. There is no XC, so there is no point of XC. R square plus XL square becomes your Z. Tan of phi becomes XL by R. Cos of phi becomes R by Z. These are the three diagrams that you will draw. This is your VR, voltage across R. This is your VL, voltage across L. This is the total voltage V. Total voltage V is ahead of total current I by a phase angle of phi. Tan of phi is XL by R. Cos of phi is R divided by Z. Z is under root of R square plus XL square. I'll give you a minute. 2 minutes. When it out, please ask. Well, I hope you have understood this. Simple case. When you have a R and a L combined together, current is behind, voltage is ahead by an angle of phi. Cos of phi is R by Z. Tan of phi is XL divided by R, and your Z is under root of R square plus XL square. Now we'll be solving this problem, a small problem. To understand this, 9 by 100 pi inductor and a 12 ohm resistor are connected in series to a 225 volt. This is the RMS value, 225 volt. 50 hertz is the frequency. AC source. Calculate the current. When I say current, it is the RMS current, and the phase angle between the current and the source voltage. Can you find out this answer for me? Inductor का inductance is 9 by 100 pi. Resistance is 12 ohms. RMS voltage is 225 volts. Frequency is 50 hertz. I'll keep quiet for a minute. You have a minute to finish for yourself. Well, I hope you have solved this problem. Now, whenever such problem comes, what you got to do is, first you need to calculate in all these problems. First, you need to calculate the value of XL or XC. In this case, it is XL. So first you will calculate the value of XL. Now, how do you calculate the value of XL? How do you calculate the value of XL? XL, inductive reactance, is omega L, omega multiplied by L. How do you get the value of omega? Omega is 2 pi F, 2 pi F into L, 2 pi F, where F is the frequency, multiplied by L, 2 pi into 50 multiplied by L. Everything gets cancelled. We have 9 ohms as the inductive reactance. I hope you have understood this. Now, that is step number 1. Step number 1 is calculate the value of XL or XC. There could be a case where you have to calculate both. If the circuit has all the 3 elements, it has L and C both, then you have to calculate XL as well as XC. Here we only need to calculate XL. That is the first step. In second step, what you need to do is you need to calculate the value of Z. Z, the impedance. In this case, the value of impedance is under root of R square plus XL square, 12 square plus 9 square, and that is equal to 15. Now remember, a very good point here. important point here, something known as Pythagorean triplets. Pythagorean triplets. Now these Pythagorean triplets are going to help you a lot, because most of the question in this Z, finding out the Z, are based on Pythagorean triplets. Now what is this Pythagorean triplet? 3, 4 and 5 are Pythagorean triplet. 3 square plus 4 square is 5 square. 3 square plus 4 square is 5 square. If I multiply this by 3, it becomes 9 square plus 12 square is equal to 15 square. So 9, 12 and 15. In fact, if I multiply it by 2, 6, 8 and 10 are also Pythagorean triplets. Now remember these Pythagorean triplets. Why you have to remember these Pythagorean triplets? You can find a number of these. For example, if I remember 12, 5 and 13 are also Pythagorean triplet. 12 square is 144. 5 square is 25. 144 plus 25 is 169. So take the root of 169, it is 13. 12, 5 and 13 are also Pythagorean triplets. Now why you need to remember these Pythagorean triplets? As many as you can. If you find out that one of these XL or XC or R is 9, the other one will come as 12. That is how questions are framed. If you find one of these values, whether it is L or X, is coming as 3, the other value will come as 4, so that the answer becomes 5. So if you remember these Pythagorean triplets, the question will become very simple. For example, if in some case you find that one of these R or X is 9, the other one will automatically come as 12, so that the answer becomes 15. One of them is 5, other will have to be 12, because the answer then will have to be 13. So you will see some calculations. If you don't want to do it, you always do it, not a problem. Anyways, having said that, we have found out the value of the impedance Z. That is your step number 2. Step number 3, you can find out the value of IRMS current, VRMS divided by Z. That is step number 3. You will get the value of IRMS current. Then you can find the value of cos of phi or tan of phi, depending on what you want to find out. Here, remember, angle is always found in terms of tan of phi. Tan inverse of 9 by 12. Tan inverse of 9 by 12 becomes 37 degrees. So the angle between voltage and current is 37 degrees. Voltage is leading current by 37 degrees. Voltage is leading current by 37 degrees. The last question that can be asked here is, what is the average power? Now there are two ways to find out this. My way is, you have already calculated the value of IRMS. You just square the value of IRMS and multiply it by R. That will give you the average power. The RMS value is 15. So 15 square multiplied by the value of resistance is 12. To multiply these two things, you will get the average power. Apart from this, there cannot be any question that can come, whether it is LR circuit, whether it is RC circuit, whether it is LRC circuit. So please remember this. I'll give you a minute to note this down. If you have any problems, please ask. Well, I hope you have understood this. This was LR circuit. In LR circuit, voltage is leading current by some angle phi. That angle phi, cos of phi is R by Z. The value of this Z is root over R square plus XL square. Now we'll move on to the second circuit, and you don't have to write all this. What you need to write is, it is a series RC circuit, and this is the diagram that you see. Now, in this, what you need to note down is what I'm highlighting. The value of Z is R square plus XC square. Previously it was XL, now it is XC. Tan of phi, if you can see, is XC divided by R. I hope you can see this. If you don't see this, I will write it here. Tan of this phi is XC divided by R. Remember, cos of this phi is always equal to R divided by Z. And as you can see here, current is leading and voltage is lagging. The angle is phi. So these are the only things that you need to note down in this entire thing. If it is a RC circuit, voltage is lagging by current by an angle phi. Tan of that phi is XC by R. Cos of that phi is R by Z. Z is equal to under root of R square plus XC square. Rest of the formulas all remain same. I'll give you a minute to finish. Well, I hope you have noted this down. Then let us solve one problem, and in this problem, we will do everything together. Everything together means whatever we have studied till now, and this is the problem. In a series RC circuit, the RMS value of voltage, as you can see, is 200 volts. Frequency is 50 hertz. Resistance is 100. Capacitance is 100 divided by pi microfarad. We have to calculate all these things. Number one is impedance. Number two is power factor ka angle, that is phi. Third is power factor. Fourth is current, means RMS current. Maximum current means I naught. Voltage across R. Oh, that means RMS voltage across R. Voltage across C. RMS voltage across C. Maximum voltage across R. Maximum voltage across C. Average power, average reactive power, and average virtual power. All these are average values. All these are average values. Let's see how many of you can do. You can solve each and everything. That means everything is clear and you can relax. I'll give you 5 minutes to solve this question. 5 minutes. Enough time to solve this. Minute. 5 minutes to win it. Well, I hope all of you are trying this problem. Do it step by step. Let me help you out in solving the problem. The first step is to find the value of xc. It's a simple calculation. It is 1 divided by omega c. It is 1 divided by omega is 2 pi into f. 2 pi into f. F is 50. So it is 100 pi. 100 pi into capacitance is 100 by pi into 10 raised to the power minus 6. So 10 raised to the power minus 6 can go on the top. It becomes 10 raised to the power plus 6. 100 pi. 100 pi. Sorry. pi and pi will cancel. 100 and 100 is 10 raised to the power 4. 10 raised to the power 4. 10 raised to the power 6 is on the top. So I will get the answer of Xc as 100 ohms. This pi and this pi getting cancelled. 3 zeros getting cancelled. So it is 1000 divided by 10. 1000 divided by 10 is 100. I hope everyone got this. If you got this, you have passed step number 1. Then you move on to find out the step number 2, z under root of r square plus xc square, 100 square plus 100 square ka root, it is 100 root 2. If you pass this step, this is step number 2. Then you find out the value of tan phi. Tan phi is xl by r. 1 angle is 45 degrees. If you have done this, pass step number 3. Step number 4, power factor is cos of phi, cos of 45, 1 by root 2. Have you done up till here? I hope so. If you have done up till here, after that, everything is pretty simple. I'll still give you a minute to do this and move ahead. A minute to win it. Win it. Win it. Well, I hope you have noted this down. Let us move ahead and do the next step. The next step is find the value of current. IRMS. IRMS is VRMS divided by Z. Z, Z, Z. Don't forget that. VRMS is 200. Z is 100 root 2. Answer is root 2 ampere. That is step number 4. Step number 4. Maximum current I naught is root 2 multiplied by RMS. So root 2 multiplied by root 2. It is 2. As simple as that. As simple as that. Voltage across R is VRMS. Across R, it is IRMS into R. RMS value of current into R will give you voltage across R. The value of R is 100. The value of IRMS is root 2. Remember, the voltage across R is IRMS multiplied by R. This is the voltage across R. What is the voltage across C? It will be IRMS multiplied by XC. Remember that, pure resistive and pure capacitive circuit. Maximum voltage across R will be root 2 times of RMS voltage. So answer is 200. Maximum voltage across C is root 2 times of the RMS voltage. Average power, active power is VRMS into IRMS into cos phi, or you can find it out using I square RMS into R. you will get the same answer. Here R means power across the register. I gave you the different question. Here PR means power across the register, and you can see power across the register is 200 volt. Power across the capacitor. Capacitor does not consume any power. Everything that we have discussed is right now on your screens. I hope you remember this. I hope you understand this. I'll give you 2 minutes to note this down. 2 minutes. 2 minutes. I hope, bacha, you have noted this down. Everything. I'll again repeat. RMS current is VRMS divided by Z. Maximum current is RMS current into root 2. Voltage across R resistance is IRMS multiplied by R. Voltage across C is IRMS multiplied by XC. Voltage across L is IRMS multiplied by XL. Average power is I square RMS into R. Power across the resistor is I square RMS into R. Power across the capacitor or power consumed in the inductor is always 0. Do we all understand this? Can we move forward? And when we move forward, we will move forward to this slide where we are seeing the 3 types of combination of L, R, and C. The first combination which we do, the first type of combination that we have already seen. The first type of combination that we already seen is the LR circuit. The second is RC. The third one doesn't come is LC. The current in the circuit, if I talk about the current, it is a series circuit. Therefore, the value of current here should be value of current. The value of current is same as L and R. Here also the value of current is same in R and C. You must read it as value of current. Here also the current is same because it is a series circuit. The value of current is same. Do we all understand this, bacha? The value of current. How much current is flowing? The value. Same current flows. Same current flows, but current and voltage are not in the same phase. Remember that. Same current flows, but they are not in the same phase. Current is same, but the angle between voltage and current is not same. I hope you understand this. I'll give you a minute to note this down. I'll give you, or what we'll do since the table is long, we'll do as revision in the class tomorrow. So you make this table where you have term coming in column number 1, you have LR coming in column number 2, you have RC coming in column number 3, and you have LC coming in column number 4, and we will discuss this. We will discuss this in the next class, which is tomorrow, because right now your time is already over. So I would not like to extend this any further. We'll meet in the next class tomorrow. I hope you enjoyed this class. I guess I could not see you or hear you, but I hope you have understood this class. You can also watch the recorded lecture anytime. Take care. Have a nice day. I'll see you tomorrow at your regular time. Bye bye. See you.